Okay, today we're going to look at solving quadratic equations using two properties. One's the square root property and or two methods. One's the square root property, one's completing the square. So far, you've really only learned factoring to solve, but in the real world, not everything is factorable. So a quadratic equation looks like ax squared plus bx plus c equals 0. A, b, and c are real numbers. And what's important is a cannot be 0, because if a is 0, basically this x squared term would go away, and then you have a linear equation. So you need this x squared term. This is what makes it a quadratic. And we're going to learn throughout this chapter 3 other methods for solving besides factoring. And we're learning 2 of them in this lesson today. Okay, so that we can solve anything, even if it's not factorable, as long as it has a real solution. So the first method we're going to learn here is the square root property. And the square root property says if x squared equals b, and we use this with the Pythagorean theorem, then you can take the square root of both sides and get x equals, and then it is a plus or minus. We didn't use this in the example in chapter 9 because it was distance. We didn't need the negative, but it is plus or minus the square root of b. So if you have some term by itself, so raised to the second power, you can take the square root of both sides and get it by itself. And so here you would take the square root of both sides and we get x equals that plus or minus square root of b. Okay, so let's practice using this. Solve 1/2 y squared equals 162. So first I need to get rid of the 1/2 before I can use the square root property. So I'm going to multiply both sides by 2, and I get y squared equals 324. Now I'm going to take the square root of both sides. And when you take the square root of 324 on your calculator, you get 18. So it's actually a perfect square. Don't forget the plus or minus. So it's 2 answers, a positive 18 and a negative 18. Now for me, and on paper, you can write that plus or minus sign. In my math lab, they don't have that. So you're going to have to write your 2 answers as negative 18, comma 18. Okay, let's do another example. First thing I need to do is get x squared by itself, so let's add 5 to both sides. And I get x squared equals 1. Take the square root of both sides, and you get x equals plus or minus the square root of 1 is just 1. Okay, in this next example, before I can use the square root property, I need to move this 4 over. So I'm going to subtract 4 from both sides of the equal sign. I get n plus 3 squared equals negative 2. I'm going to take the square root of both sides, and I get n plus 3 equals plus or minus the square root of negative 2. Now the problem is I have the square root of a negative number, which we said was a non-real answer. So we're going to stop here because this is not a real solution. Okay, for D, solve using the square root property. I'm going to factor the left-hand side. This is a perfect square trinomial, and by that I mean both of the factors are going to be the same. What multiplies to be 16 adds to be negative 8 is negative 4 and negative 4. So perfect square trinomial, you have the same factors. So I can write this instead of x minus 4 times itself as x minus 4 squared equals 12. You can now use the square root property, so take the square root of both sides, and you get x minus 4 equals plus or minus the square root of 12, and we have simplified the square root of 12 before. Remember, this is 4 times 3, and the square root of 4 is 2, so it's 2 square root of 3. Now the last step is you want to get x by itself, so I'm going to add 4 over to the other side, and this 4 needs to go in front of the plus or minus sign, not behind it. So it's going to become 4 plus or minus 2 square root of 3. So those are our 2 answers, 4 plus 2 square root of 3 and 4 minus 2 square root of 3. Okay, the second method we're going to learn is completing the square. And the goal when completing the square is to make one side of the equation a perfect square trinomial, just like we saw on the screen before. So for an example, we could have x plus 1 squared. So you have the same two factors. Some examples of perfect square trinomials, if I use, I'll start with 1, so I'd have x squared plus 2x plus 1. If I do 2, I have x squared plus 4x plus 4, 3, x squared plus 6x plus 9, etc. In general, a perfect square trinomial can be found by looking at the relationship between b and c. Each one of these has a relationship between the number b and the number c. And what that relationship is, you have x squared plus bx plus, the way to get c, to create a perfect square trinomial, is you have to take that number b, divide it by 2, and square it. So if I show you over here, if I take this 2 divided by 2, I get 1, 1 squared is 1. If I take 4 divided by 2, I get 2, 2 squared is 4. Take 6 divided by 2, I get 3, 3 squared is 9. So this is how you create a perfect square trinomial. So let's practice making the following perfect square trinomials. So the rule says take the number in front of x, in our case here it's 12, divide it by 2 and square it. So 12 divided by 2 is 6, 6 squared is 36. And notice there's a plus sign here because it doesn't matter whether your number is positive or negative. Any number, positive or negative, when you square it becomes positive. So this is always going to be a plus. Let's do the same thing over here. Take the number in front of x, which is a negative 7, divide it by 2 and square it. And that becomes a positive 49 over 4.